All right, here we go with 3.7, practice understanding tasks. This is just going to tie up everything that we've learned so far, and it's just a bunch of practice problems that we're going to do. So let's get started. Carlos and Clarita, Tia and Tehani, and their best friend Zach are all discussing their favorite methods for solving quadratic equations of the form ax squared plus bx plus c equals 0. Each student thinks about the related quadratic function y equals ax squared plus bx plus c as part of his or her strategy. Carlos says, I like to make a table of values for x and find the solution by inspecting the table. Zach says, I like to graph the related quadratic function and use my graph to find the solutions. Clarita says, I like to write the equation in factor form and then use the factors to find the solutions. Tia says, I like to treat it like a quadratic function that I put in vertex form by completing the square. I can then use the square root to undo the squared expression. And Tehani says, I also like to use the quadratic formula to find the solutions. So demonstrate how each student might solve each of the following quadratic equations. All right. So Carlos likes to make a table. So we need to know x squared minus 2x minus 15 equals y. And Carlos would make a table like this, x and y, and he would figure out what x would make it equal to 0. So let's start just with 0. So that would give us 0 times 0 minus 2 times 0, so that's just 0, minus 15. So this gives me negative 15. If I plug in 1, I get 1 minus 2 minus 15. So that would be 1 minus 2 is negative 1, minus 15 is negative 16. If I plug in 2, I get 4 minus 4, which is 0, which is negative 15. If I plug in 3, I get 9 minus 6, that's going to be 3. 3 minus 15 is negative 12. If I plug in 4, I get 16 minus 8 minus 15. 16 minus 8 is going to be 8. Minus 15 is negative 7. And then if I do number 5, if I plug in 5, that gives me 25 minus 10, so that's 15, minus 15 is 0. So 5 is a solution because according to Carlos' strategy, if I plug in 5, I'm going to get 0. So if I plug in 5, I'm going to make an equation that equals what it's supposed to equal. Looking at the table, I noticed that 16, like going up from 16 and going down from 16 is the same numbers because you get negative 15, negative 15. And I can use that to work backwards to figure out what the other 0 is. So if I count how many steps down it took, 1, 2, 3, 4, then that's how many steps up it's going to take. So it'll go 1, 2, 3, 4. Negative 1, negative 2, negative 3. Right, so that would be 1, 2, 3, 4, negative 3. So the answers that Carlos would get would be negative 3 and 5. Okay, Zach says that he would like to graph the equation. So there's a lot of different ways to graph. One of the most basic ways is you can just graph using a table. So in Zach's strategy, let's say that he started by making a table first and he got 15 and then he got 1 and negative 16 and 2 and 15 like this. He would have noticed that it was making a parabola, and then he also would have noticed that the stretch factor is 1, so he would have been going like this, 1 and then 3 and then 5 and then 7, and that's how he could have graphed it, because he would have said, okay, that's 15, and then he could have graphed it that way, 1 and then 3 and then 5 and then 7. Zach would have to be very careful with an actual graph paper to be able to graph it. I don't have graph paper here, but he would have to be real careful with graphing to make sure that he's landing on the right spots. And so what he would get is he would actually land on 5 and on -3, and that's where the y would equal 0. That's where it would equal 0. So he's looking for where it crosses the x-axis. Clarita likes to write the equation in factor form. So if you factor this, you're looking for two numbers that multiply to -15 and adds up to -2. And that would be -5 and 3. So we can factor it like this. And then you can use these factors to find the solutions by just solving each factor equal to 0. So x, based on this, I know x can equal 5, and that will make it 0. And based on this, I know x can equal -3, and that will make it 0. So that is another way to find the solution. Tia likes to write it in vertex form. So that would mean that you're going to write x squared minus 2x plus 1 minus 1 minus 15 equals 0. And the reason that she would add 1 is because she would take -2, cut it in half, square it, and you get 1. So you're adding 1, and then you can't just add 1 because that messes up your equation. So you have to also subtract 1. That way it's like you didn't do anything. This you can re-represent it as x minus 1 squared. And then -1 minus 15 gives you -16 equals 0. And then you can solve this using the strategy from before. So you can add 16 to both sides, square root both sides. And so you get x minus 1 equals plus or minus the square root of 16, which is 4. And then you can add 1 to both sides. So x equals 1 plus or minus 4. 1 plus 4 equals 5. 1 minus 4 equals -3. And those are your two answers in there as well. And Tehani likes to use the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac over 2a, like this. So we can substitute in these values into here. B is -2, so we can put -2 in here. That makes it +2. Plus or minus the square root of -2 squared would be 4. Minus 4 times a, which is 1, times c, which is -15. So 4 times 1 times -15 is going to be -60, over 2 times a, and a is 1, so over 2. 4 minus -60 is going to be 4 plus 60, so that's 64. 2 plus or minus the square root of 64 over 2. That would be 2 plus or minus 8 over 2. And so now you have two options. 2 plus 8 is 10, over 2 is 5. 2 minus 8 is -6. -6 over 2 is -3. And again, you get the same answers. So here we solved this problem. We solved this equation in 5 different ways. Okay, let's continue. Okay. Carlos is going to use his strategy of writing a table. And we're looking at 2x squared plus 3x plus 1 equals y. So Carlos probably is going to start with 0. And if he plugs in 0, he's going to get 1. Then he's going to plug in 1. And when he plugs in 1, he's going to get 2 times 1 squared is 2, plus 3 is 5, plus 1 is 6. Okay. Then he's going to plug in 2. 2 times 2 squared is 2 times 4, plus 3 times 2 is 6. So we have 4 times 2, which is 8, plus 6, that's 14, plus 1 is 15. Carlos would probably notice that these are increasing by larger amounts. And he'd probably think, oh, well, I'm never going to go back down to 0. It's just going to keep getting bigger and bigger. So he would work backwards. What happens if he plugs in -1? So if he plugs in -1, he would see, let's go. This would be a 5, excuse me. If he plugs in -1, he would see this would turn into a 1 times 2 is 2. That's 2. -3. So 2 minus 3, that would be -1, plus 1 is 0. So he would get a 0 there. And that would be one of the solutions. So he's got x equals -1 as one of his solutions. He could work backwards a little bit and figure out where his other solution is. He could plug in -2. That would give you 4 times 2 is 8 minus 6. So 8 minus 6 is 2 plus 1 is 3. Is that right? 8 minus 6 plus 1 is 3. And it's already positive again. So it must have crossed an additional time somewhere in there, and he doesn't have access to that information. So Carlos could only find this solution. Zach would probably try to graph it the same way. He would get -1, 0, which would be like there. -2 and 3, 1, 2, 3 would be like here. 0, 1 would be here. 1, 6 would be like 3, 4, 5, 6 would be up here. And 2, 15 would be off the graph. So it looks something like this. And so Zach wouldn't necessarily be able to know where like it crosses there, but he would see this cross and he would get the same answer as Zach, that it crosses at -1. Clarita likes to factor it. So to factor this, what we can do is we can look for two numbers that multiplies to 2 and adds up to 3. So we can do like 1 and 2. 2x squared plus 2x plus 1x plus 1, like this. This is called factoring by grouping. We can factor out 2x over here. This gives us x plus 1, and we can factor out 1 over here. And that's going to give us 2x plus 1 and x plus 1. And Clarita knows that you just solve these for 0. So this one, if this equals 0, you can subtract 1 to the other side. And you get 2x equals -1, and then divide by 2, and you get x equals -1/2. No wonder that Carlos and Zach couldn't find this, because x had to equal -1/2. They would have had to plug in like half values, fractional values, in order to be able to solve it. And then if Clarita solves this one, x minus 1 equals 0, or x plus 1 equals 0, you can subtract 1 and you get x equals -1, which Carlos and Zach were able to get. Tia's strategy is to write it in vertex form. 2x squared plus 3x plus 1 equals 0. To write this in vertex form, we have to first factor out the 2. 2x squared plus 3 over 2x plus 1 equals 0. We cut this in half, so that gives us 3 over 4, and we square it, which gives us 9 over 16. So we're going to do 2 times x squared plus 3 halves x plus 9 over 16. We also want to subtract. Because we added 9 over 16 times 2, we need to subtract 9 over 16 times 2, which is 18 over 16. This means that, which by the way, this is 16 over 16. So we can do this. 2 times x plus 3/4 squared. One moment. So this gives us x plus 3/4 squared. And then this would be minus 2/16 equals 0. This would be the, if we reduce this, this would be 1/8. We can add 1/8 to both sides. So you get 2 times x plus 3/4 squared equals 1/8. You can take half of both sides. All right, divide both sides by 2. And that's going to give you x plus 3/4 squared equals 1/16. Take the square root of both sides. You get x plus 3/4 equals plus or minus 1/4, because the square root of 1/16 is 1/4. Subtract 3/4, x equals negative 3/4 plus or minus 1/4. So negative 3/4 plus 1/4 is negative 2/4, which is negative 1/2. Negative 3/4 minus 1/4 would be negative 4/4, which is negative 1. And so those are your two answers. And those are the same two answers that Clarita got. This is Tia's strategy. Which one do you think was a better strategy? Was more efficient? Tehani's strategy is to use the quadratic formula. So she would write x equals negative b. B is 3. So this would be negative 3 plus or minus the square root of b squared. So 3 squared would be 9 minus 4 times 2 times 1. 4 times 2 is 8 times 1 is still 8 over 2 times a, which is 2 times 2, which is 4. Let's simplify this. X equals negative 3 plus or minus the square root of 1 over 4. 1 over 4 is, or square root of 1 is just 1. So x equals negative 3 plus or minus 1 over 4. Negative 3 plus 1 is negative 2 over 4 is negative 1/2. Negative 3 minus 1 is negative 4 over 4 is negative 1. So same answers as before. Interesting to note is that whenever the solutions are fractions, it's harder for Carlos and Zach to have a good answer. It's not impossible. If Carlos had been plugging in halves, he would have gotten it. And same thing with Zach. But it is more difficult for them. Okay, over here, Carlos would be starting by plugging in values. X squared plus 4x minus 8 equals y. He would probably start with 0 and see what happens. So 0 plus 0 minus 8, that gives you negative 8. And then you would plug in 1. 1 plus 4 is 5, minus 8 is negative 3. Then you plug in 2. That would be 4 plus 8 minus 8. So that would be 4 plus 8 minus 8 would be 4. So Carlos would say, wait a second, I went from negative to positive. So there's the 0 is somewhere in between here. There's an x, there's a solution somewhere between 1 and 2. Then Carlos would probably try to plug in negative values. So if he plugged in -1, that would be 1 minus 4 minus 8. That's -12. That would be -11. And then he'd plug in -2 maybe. You would get 4 minus 8 minus 8. That's -16 minus 4. That would be -12. And then he would plug in maybe -3. And that would give him 9 minus 12. 9 minus 12, which would be 3 minus 8 would be -5. Did I do that right? No. 9 minus 12 was -3 minus 8 would be -11. So if he plugged in -3, he'd get -11. Carlos would then notice that the numbers are starting to repeat backwards and forwards from this value, and he knew that this is the vertex. So because he knew, hold on just one second. So Carlos would see that it's starting to repeat going that way, the same as going this way, and he could count. He would say 1, 2, 3, and a little bit more. Right, so because it takes 1, 2, 3 jumps, and then a little bit more, and not 4, because then that's too many, but like 3 and some more away from here, and then 3 and some more away from there. So if -2 is the vertex, 3 going this way would be 1, and some more, which is 2. So there's a solution somewhere between 1 and 2. And from -2, 3 going this way would be -5, and then some more would be -6. So that means there's going to be a solution somewhere between there. And he could probably try plugging in some fractions and seeing if he could get an answer. Zach's strategy would be very similar, because if he's trying to graph it, he would probably graph using a table. He might graph by using one of these other ones where you turn it into factored form or into vertex form and then graph it that way. It depends on how Zach likes to graph, right? If Zach likes to graph by using a table, he's going to have a little bit of trouble. If Zach likes to graph using factored form, or if he likes to graph using vertex form, he's going to get different results. In this case, if we try to graph this, we know that there's going to be a point at 0, -8, at 1, -3, and at 2, 4. And there's a point at -2, -1, -11, -2, and 12. And it's going to go like this. Right, so somewhere in here between 1 and 2, there's a solution. It's going to cross somewhere in there. And then 1, 2, 3, 4, 5, and then 6. Somewhere between 5 and 6, it's going to cross there. But he won't know where if he uses Carlos' strategy. If Clarita tries to use her strategy, she's going to try to factor it, look for 2 numbers that multiply to be -8 and adds up to be 4. And she would try different numbers that multiplies to be -8. So you could try 1 times 8, 2 times 4, and that's it. And neither of these strategies has a way to add up to 4. So Clarita would be stuck unless she started trying other ways to multiply to equal -8. Tia would just complete the square. Right, so x squared plus 4x, that means we need a 4 over here. So we're going to subtract 4 and subtract 8. Then this becomes x plus 2 squared. -4 minus 8 becomes -12. You can add 12 to both sides. Square root both sides, plus or minus. The square root of 12 would be 2 root 3. and then subtract 2 from both sides. Okay, no wonder these other people couldn't figure out the problem, because the solution, the two solutions have this irrational number, right? It would help if you could see. The square root of 3 is an irrational number. The closest we can get to it is a decimal approximation, or we can just write it this way. So that means even if Carlos had tried to plug in fractions, he wouldn't have gotten an answer, because the answer is not a fraction. It's an irrational number. So Carlos's strategy, Zach's strategy, and Clarita's strategy, well, Carlos and Clarita's strategy definitely wouldn't work. Zach's strategy might have worked if he graphed using vertex form, maybe. So there's two solutions. We know the line of symmetry is -2. So the first solution would be -2 plus square root of 3, or 2 square root of 3. The other solution would be -2 minus 2 square root of 3. Tehani's strategy would be to plug in these values into the quadratic formula. X equals -4 plus or minus the square root of 4 squared minus 4 times 1 times -8, which is -32, over 2 times a, which is 2. So this equals X equals -4 plus or minus the square root of 16 plus 32, which is 48. Which is 48 over 2. The square root of 48 it's 16 times 3. So 48 is 16 times 3. I can take the square root of the 16. That would be -4 plus or minus 4 root 3. And then the 2 can simplify there, and that would give me -2 plus or minus 2 square root of 3, which is the same answer that Tia got. So Tehani's strategy and Tia's strategy are still working. Okay. It says, describe why each strategy works. Well, Carlos's strategy works because it's almost like guess and check, right? It works through trial and error. Now, Carlos can be smart about the numbers that he picks so that he doesn't have to do as many trials, but he can be looking for patterns, but he's really just kind of continuing to plug in numbers until he gets the one that equals 0, right? And so it's kind of trial and error. Carlos' strategy doesn't work if it's an irrational value, though. Zach's strategy is similar to Carlos' strategy. It works when Zach's strategy works when the graph crosses the x-axis. When the parabola crosses the x-axis. Clarita's strategy, why does it work? It works because she's able to find a way to make it equal 0 through multiplication. Clarita is able to make y equal 0 through multiplication. That's why it's in factored form. Tia's strategy and Tehani's strategy work for the same reason, because Tehani's strategy, remember back in 3.5 when we talked about the quadratic formula, the quadratic formula is really just solving by completing the square and by writing in vertex form, except you do all of it with letters and then you just plug in. So what that means is that the quadratic formula is really the same thing as solving by putting it in vertex form. So those both work, and they work because you're able to restate the expression using only a single x, and you can take the square root. So TIA strategy works because you're just solving for x. Like you're canceling stuff. As the students continue, let's look at the next problem. As the students continue to try out their strategies, they notice that sometimes one strategy works better than another. Explain how you would decide when to use each strategy. This is up to your explanation, right? You get to decide when you would use each strategy. So I recommend you pause the video, fill in when you would use each strategy, and then come back and I'll explain my opinion. Okay, welcome back. So you just unpause the video. My opinion is that you would only use Clarita's strategy if it was easy to use. Like if you could factor it, then you would use Clarita's strategy. And if that didn't work, then I would decide to use Tehani's strategy. Because Tehani's strategy is the same as Tia's strategy, except Tehani's strategy is already, like, you've already solved it once with the formula, so then you don't need to solve it again. Now, if I had a test, if my teacher was like, make sure that you know these different strategies, then I would obviously try to use each different strategy the way my teacher wanted. But in general, you want to see if you can factor it. And if you can't factor it, then use either Tia or Tehani strategy. Carlos's strategy doesn't always work, right? It only works if the solutions are integers or if they're fractions. And if they're fractions, it's a lot of extra work. And Zach's strategy kind of has similar problems to Carlos's strategy. Zach's strategy, he could graph using other methods. So if Zach graphed using factored form, or if Zach graphed using vertex form, then he would have the strength of those forms already. But at that point, why wouldn't you just solve using that strategy? Like Zach could save some work. If he's going to graph from factored form, he might as well just solve it using Clarita's strategy, because Clarita's strategy is to use factored form. Or if Zach is going to write it in vertex form, he might as well just solve it in vertex form, because Tia, that's how Tia is doing it anyway. The only time that I could see Zach's form being super useful is if the equation was already graphed and you could tell where it was crossing the x-axis, like you could just visually see, because then it's very fast to use it, Or I would use Zach's strategy if I was explaining it to somebody. If I was explaining how to solve, then I would probably do all the different forms, just so that whoever I was explaining it to could see. But if I'm just trying to solve it as fast as I can, I would try Clarita's strategy. And if that didn't work, then I would use Tehani's strategy. Okay, next, it says, here is an extra challenge. How might each student solve the following system of equations? I'm going to let you try this strategy for yourself. But I will show you one method which I think Tia would use. Okay, and you can do the rest. And by showing you Tia's strategy, I think that you can see the answers, and then you can try seeing the other ones. Like Carlos would probably just make a table and plug in different values until they equal each other. Clarita would, I don't know what she would do. She would try to factor maybe, because she likes factoring. She would probably try to factor this. Here's what I think Tia would do. I think she would say, well, I need these to equal each other. So they're going to equal each other. And then I'm going to solve it. And she would subtract x from both sides. And so she would add 3 to both sides. And then that turns into an equation that we already know. And it turns into an equation that's factorable. Tia wouldn't factor it though. She would write it as a vertex form equation. You know what? I know what Clarita would do now. So Clarita would do the same as Tia, and then when she gets to here, she would factor it. What Tia would do here is she's going to write x squared minus 5x, and then she's going to write this in vertex form. So she would cut this in half, get 5 over 2, square it for 25 over 4, and add that. She would add 25 over 4 and subtract 25 over 4, add 4. This would turn into x minus 5 halves squared. This would be 16 over 4. Negative 25 over 4 plus 16 over 4 would be negative 9 over 4. And then she would solve that. She would get x minus 5 halves equals 9 over 4, the square root of that plus or minus, which would be 3 halves. So then she would get x equals 5 halves plus or minus 3 halves. 5 plus 3 would be 8. 8 over 2 would be 4, so x can equal 4. 5 minus 3 would be 2. 2 over 2 would be 1, so x can equal 1. And those would be the solutions that Tia would get. Like I said, Clarita would probably stop here and she would factor it. Tehani would probably stop here and plug it into the quadratic formula. Carlos would probably graph this. Zach would probably graph this. And Carlos could either plug in different x's until they matched, or he could do this and then plug in different x's until it equals 0. Okay, let's do some ready, set, goes. This says, the given functions provide the connection between possible areas that can be created by a rectangle for a given side length x and a set amount of perimeter. You could think of it as the different amounts of area you can close in with a given amount of fencing, as long as you always create a rectangular enclosure. Okay, so find the following. What I see here is the area, and this is the width, and this could be the length, for example. So the area of 3 times 10 minus 3 is 3 times 7. That would be 21. This would be 4 times 6, which would be 24. This would be 6 times 4, which would be 24. And when would the area be 0? The area would be 0 if x was 0 or if x was 10. Right? If you put a 0, then it would equal 0. If you put a 10, it would equal 0. Because if you put a 0, you'd get 0 times 10. If you put 10, you get 10 times 0. So that's why. When is a of x at its maximum? So I noticed that these two are the same. So that tells me the parabola is like, and I noticed that 3 is lower. So I can kind of visualize that like 1, 2, 3, 4, 5, 6. 3 is lower than 4, 4 is higher, and then 6 is the same. So I think the parabola is going like this. And I think if you plug in 5, you're going to get right in the middle. So if you plug in 5, you get 5 times 5, which is 25. So when x equals 5, a of 5 equals 25. And I think that's the maximum because of that explanation. Okay, let's go over here. If I plug in 10, I get 10 times 40, which is 400. If I plug in 20, I get 20 times 30, which is 600. If I plug in 30, I get 20 times 30, which is 600. When does it equal 0? If x equals 0 or if x equals 50. When is it at its maximum? Here's another thing I noticed. If these are the x-intercepts, that means the line of symmetry is exactly in the middle when it's 25, right? Between 0 and 50, the middle is 25. So that means automatically the line of symmetry is going to be the maximum, or that will be the x value of the maximum. So the line of symmetry is when x equals 25 based on this information. So if I plug 25 here, 25 times 25, that's going to be 625. And that's the maximum, right? At 25 and 625 at this point right here. Okay, let's keep going. Find the following. So if I plug in 20, that's 20 times 55. So that's going to be 1,100. Is that right? Yeah, 20 times 55, that's right. If I plug in 35, I get 35 times 30. And 35 times 30 is going to be 15, 1050. If I plug in 40, I get 40 times 35. This would be 35 times 40. I messed it up. Okay, 0 times, yeah, that's fine. 4 times 5 is 20. 4 times it's 12. Okay, so that's actually 1,400. If I plug in 40, I get 40 times 35, which is going to give me the same answer. When is it 0? It's 0 when x is 0 and when x is 75. I noticed that these two are the same value. So in the same way, I know my line of symmetry is going to be exactly in the middle between 40 and 35. And that would be, what's between 40 and 35? That would be 37.5. So when x equals 37.5, that's the line of symmetry. And that's when it's going to be at its maximum. Okay, let's keep going. If I plug in 10, I get 10 times 38, which is 380. If I plug in 20, I get 20 times 28. 20 times 28. That'll be 0, 16, 0, 0, and 4, 560. If I plug in 28, I get 28 times 20, which is 560. It'll equal 0 when x is 0 and when x is 48. And exactly in the middle between those two is going to be the line of symmetry, which is 24. When x equals 24, it'll be at its maximum. You could also tell the line of symmetry because between 28 and 20, since these are the same, that means the line of symmetry is exactly between 28 and 20, which again is 24. Okay. Let's do the set. For each of the given quadratic equations, find the solutions using an efficient method. State the method you are using as well as the solutions. You must use at least 3 different methods. Okay, at least 3. I'm thinking I'm going to use Clarita's method of factoring, Tia and Tehani's method of completing the square and vertex form and the quadratic formula. So let's go through. Here, 60 is 12 times 5, and that I can factor really easily. And so I can solve this really fast. Negative 12 and x equals negative 5. Okay, so that was called factoring. 39 is 13 times 3, which I can also factor. X plus 13, x plus 3. So x can equal negative 13 or x can equal negative 3. Again, that's factoring. This one I can't factor because the only things that multiply to be 5 or negative 5 are negative 1 times 5 or 1 times negative 5, and that doesn't equal 7. So we're going to use, let's go ahead and use Tia's method of completing the square. So we can do x squared plus 7x plus 7 cut in half is 7 over 2. Squared would be 49 over 4 minus 49 over 4 minus 5. We're going to write 5 with a common denominator though. So that would be minus 20 over 4. This gives me x plus 7 over 2 squared. And then that comes from here. And then minus 49 minus 20 is negative 69 over 4. And if I solve that, I'm going to get x equals negative 7 halves plus or minus the square root of 69 over 2. And 69 doesn't have a square root. Okay, over here, can I factor this easily? So I'm looking for two numbers that multiply to negative 15 and adds up to 14. Yes, because I can do 3x squared plus 15x minus 1x minus 5. And I can factor out 3x here. Times x plus 5. Factor out negative 1x there, or negative 1 there. X plus 5. That's going to give me 3x minus 1 and x plus 5. So x can equal negative 5 or x can equal 1/3. That's factoring. This was called completing the square. This one's factoring. This one will be really easy to complete the square actually. All I need to do is take this, cut it in half. So that will give me 6 and square that. 6 times 6 is 36. I can add 36. I can actually add it to both sides instead of adding and subtracting it. Negative 8 plus 36 is going to be 28. So this gives me x minus 6 squared equals 28. So x can equal 6 plus or minus the square root of 28, which will be 2√7. Okay, it did say to use 3 methods, so we're going to use the quadratic formula for the last method. We need to put it in the proper form, and then we can use the quadratic formula. X equals negative 6 plus or minus the square root of 36 minus 4 times 1 times negative 7, so that's negative 28, over 2 times 1. 36 minus negative 28, that's going to be 64. That's negative 6 plus or minus 8 over 2, which you get 2 answers out of that. Negative 6 plus 8 is 2 over 2, which is 1. And negative 6 minus 8 is negative 14 over 2, which is negative 7. Those are my 2 answers. Okay. Summarize the process for solving a quadratic by the indicated strategy. Give examples along with the written explanation. Also indicate when it is best to use this strategy. I'm going to leave these to you. It's asking for you to summarize. It'll be best if you can summarize. I've explained it multiple times. And now it's time for you to take ownership and you can summarize there. Okay, let's do the go. Graphing quadratics and finding essential features of the graph, solving systems of the equation. Graph the quadratic function and supply the desired information about the graph. Okay. So we can find the y-intercept real easy if we plug in 0. We know that's 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's off the graph. But we know that the y-intercept is 0, 13 if we plug that in. For x-intercepts, we're going to have to solve this, I think. So that's going to be, or at least write it in vertex form. That's going to be x squared plus 8x plus 16 minus 16 plus 13, so that's minus 3. That's going to be x plus 4 squared minus 3. So the vertex is going to be at -4, -3. 1, 2, 3, 4, -3. And we can graph a little bit using our parent function. From here, that would go 1, 2, 3, 4. Oh, one more. Not that one. 1, 2, 3, 4, 5. There. Our x-intercepts are, you can see they're crossing here and here, but we don't have values for them. We're probably going to have to solve this. So to solve this, add 3 to both sides, square root, and then subtract 4. So x would be -4 plus or minus the square root of 3. And the line of symmetry would be x equals -4. 0. Okay, let's do this one. So already we know the y-intercept is going to be -1, because if we plug in 0, we get -1. So that's already the y-intercept. Right. Plug in 0, 0 minus 0 minus 1. That's how we get that. To find the vertex and the line of symmetry, we can write this in vertex form. So we can write this as x squared minus 4x plus 4 minus 5. This becomes x minus 2 squared minus 5. And so our vertex is going to be at 2, -5. And the line of symmetry will be at x equals 2. 1, 2, 3, 4, 5. Start filling in. Just like that. The x-intercepts, again, we can't tell from the graph, but we can solve this. We would add 5 to both sides and take the square root. So that's the square root of 5 and then add 2. X equals 2 plus or minus the square root of 5. Those would be your x-intercepts. Okay, solve each system of equations using an algebraic method and check your work. So this is a throwback to math 1 and even to some earlier math where you're solving systems of equations. We can solve this one by elimination if we just subtract the bottom equation from the top equation. So 3x minus 3x would be 0. 5y minus -2y would be like 5y plus 2y, so that's 7y. And 15 minus 6 is going to be 9. So y has to be 9/7. Knowing that y is 9/7, if we can write 3x minus 2 times 9/7 equals 6. That'll be 18/7. 3x minus 18/7 equals, let's write this in sevenths as well, 42/7. We can add 18/7 to both sides. So 3x equals 60/7. Divide by 3 on both sides, we get x equals 20/7. So the solutions are 20/7 and 9/7. Like that. Okay. Here, we can set these equal to each other. Since they both equal to y, we can set them equal to each other. Negative 7x plus 12 equals 5x minus 36. We can add 7x to both sides. 12 equals 12x minus 36. We can add 36 to both sides. 48 equals 12x. Divide by 12, 4 equals x. So if we know x equals 4, we can plug that into here. That'll give me 20 minus 36, which is negative 16. So y has to equal negative 16. So our point would be 4 and negative 16. Okay, let's keep going. Okay, we can use the same strategy here because they both equal y. We can just set them equal to each other. 2x plus 12 equals 10x minus x squared. We can add x squared to both sides and subtract 10x from both sides. So that's going to give me x squared minus 10x on both sides gives me negative 8x plus 12. Can I factor this? Yes. X minus 6 and x minus 2. So x can equal 6 or x can equal 2. The reason why there's two solutions is because this equation is a parabola like this, and this equation is a line. So there's two parts where it will cross. That's why there's two solutions. So we need to plug in each of these and see what the y is. If I plug in 2, I get 4 plus 12, which is 16. So y equals 16. 1 point is going to be 2/16. If I plug in 6, I get 12 plus 12, which means y will equal 24. So the other answer will be 6, 24. These are the 2 points like this where it's going to cross. The line will cross the parabola. Okay, let's do number 19. Same deal. Let's do it. 24x minus x squared equals 8x plus 48. I am going to add x to both sides and subtract 24 from both sides. So that's going to give me 0 equals x squared minus 16x plus 48. 48 is 12 times 4, which I can factor x minus 12, x minus 4. So x can equal 12 or x can equal 4. If I plug in 12 into here, I'm going to get 96 plus 48. 96 plus 48 is going to be the same thing as 100 plus 44, so it's 144. If I plug in 4, that's 32 plus 48, which is 80. So our 2 points are 12, 144 and 4, 80. And that makes sense because this equation, like I said, this equation is going to be a parabola and this equation is a line. And so it crosses twice. So that's why you get two solutions. And that is the end of 3.7. Thank you very much. And I will see you for 3.8.